Hello Math 152 students. In this video we're going to take a look at Chapter 7, pick out some topics, and also take a look at some StatCrunch usage. In Chapter 7 we are going to be primarily focusing on 7.1 and 7.2. I'll be posting a PowerPoint later in the week about 7.3 and 7.4, but you don't actually have any homework problems out of 7.3 and 7.4. They all come out of 7.1 and 7.2. So we want to focus on those a little bit more heavily and understand the vocabulary and theory in 7.1 and then how to do some calculations in 7.2. I want to point out the format of how 7.1 starts off. We're going to be focusing on the normal distribution primarily, but your book starts off with the uniform. Think about the uniform distribution as a flat curve or a block, this rectangle. And we saw this distribution shape in Chapter 2, but didn't do a whole lot with it. So in Example 1, you want to make sure you read carefully through this example, how they're setting up a context for the uniform. But then I want to guide you through a little bit of the vocabulary. In previous chapters, we were dealing with probabilities and tables. In Chapter 6, we would set up outcomes and probabilities, whether it was just a discrete random variable that was a customized or it was a binomial. And we knew that we could add up the probabilities and they should equal 1, and we shouldn't have negative probabilities. Those concepts and how we use probabilities are going to translate to curves or graphs in Chapter 7. Instead of the table probabilities summing up to 1, we're going to have the area under the curve. So the area under the curve has to equal 1, and we can interpret those areas under the curve as probabilities. And then the other thing is our probabilities can't be negative. This is going to be our height. We can't have our y values or our heights be negative. So you want to read carefully through the first few examples where we utilize the uniform, and then we start to transition to normal curves. So you want to read carefully through the normal curve examples. They review some things such as empirical rule, and instead of using the empirical rule again in Chapter 7, we're sort of going to move beyond the empirical rule. Notice the empirical rule tells us what to do if we're exactly 1, 2, or 3 standard deviations above the mean, but doesn't tell us what to do if you're 1.5 standard deviations or 2.5 standard deviations above the mean. So that's going to be one of our goals in 7.2, how we utilize StatCrunch or a table to do some more probabilities beyond just these. So make sure you read through 7.1 carefully, and let's go ahead and jump to 7.2. So your book starts off with an example of how to find and interpret the area under a normal curve. And if you're going to do area by hand or with a table, you have to go through z-scores. Even if you utilize StatCrunch, we want to make sure we have a firm grasp on z-scores, how to calculate those, and how they translate to a curve. So as a refresher, we always subtract the mean and divide by the standard deviation for a z-score. We have our x, which is typically our data point, and our mean and our standard deviation. In a standard normal curve, we can always say that the mean is 0 and the standard deviation is 1. But then if it's not a standard normal and you don't have a mean of 0 and a standard deviation of 1, you can standardize, or here they call it standardizing a normal random variable, by taking the z-score and then thinking about everything in terms of z-scores. If you're going to use StatCrunch, finding a z-score first is not a requirement, but it can often be helpful if we want to do an interpretation or kind of justify our answer. So you would want to read through this introductory part. They give you an example of calculating a z-score, and then let's go ahead and just jump into a first example. So I want to go over example 1 with us and take a look at what they're doing by hand and then how to translate that to StatCrunch. So they tell us a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with a mean of 38.72 inches and a standard deviation of 3.17 inches. Use the normal model to determine the proportion of 3-year-old females that have a height of less than 35 inches. As soon as I read this, I like to draw my curve. And notice in both the by hand and StatCrunch or technology examples, they draw a curve. So draw a normal curve, put your mean in the middle, and I don't always label my first standard deviations above and below, but I would go ahead and label my 35. My females less than 35 inches are all below average. So notice if we're wanting the proportion, or you could think about that as the decimal version of the percent, the proportion less than 35 is going to be less than 0.5 or less than half because we're below average. So if you can go ahead and visualize where your 35 lies in relationship to your mean, then you're already one step closer to finding your answer. You know it's going to be less than 50%. So if we're doing the by hand version, your book indicates you should find the z-score and then use a table. So to find the z-score, we can use our 35, subtract the mean, divide by the standard deviation, and we could think about a patient with a height of 35 inches would have a z-score that's negative 1.17. Then what your book does is utilizes table 5, and they go over how to use this table 5 in that previous example that we just saw, or that introductory part, and they use the negative 1.17. You have to use the columns and the rows to do this, and they find the area, they kind of have this highlighted in the red, that we're looking for. So you can take a look at the previous part in this book about how to use that table, how to scan over and read that, but it will give it to you, and we had to find our z-score first. What I want to show you is our shortcut. StatCrunch allows you to bypass the step of using the z-score and calculate this area directly if you input the mean and standard deviation. So let's jump over to StatCrunch. And let's see, we just want to open up a blank page here. And you want to go into Stat and Calculators. In Chapter 6, we were using the custom and then also the binomial. In this section, we want to use the normal. And your book starts with the standard normal, a mean of 0 and a standard deviation of 1, and that's the default on StatCrunch. If we want something else that's not dealing with z-scores, we have to input it. So for our book, let's see, we had a mean of 38.72. And then we had a standard deviation of 3.17. Now notice when I just entered that in, it redraws my curve, but then it gives me some funky stuff here. Notice it had a 0 in this probability part, and then it gives me scientific notation. What it's saying is the probability of less than or equal to 0, in this case a height less than or equal to 0, is so small. Notice this scientific notation would mean take that decimal place and move it 34 places to the left, so it's practically 0, but this is not what we want at all. What we want is actually the probability that we're less than 35 inches. So when you don't have appropriate bounds on StatCrunch, it doesn't really know what to do. But if you, or doesn't give you something that's helpful, I should say. But when you adjust your bounds appropriately, it draws that picture, kind of like your book, and it gives you a probability. So to 4 places, this is 0.1203. Let's just go back and compare. Okay, so notice our book tells us 0.1203. And then notice what happens if you're looking at the book. Notice the exact answer is not going to match up with the table answer. The table values are rounded, and so we can run into some places where a lot of times they'll say round to 2 decimal places or round to 3, but you are going to see some discrepancies with the table and then when we use the table in reverse. So notice here your book cautions you that the problem is in the fact that you rounded the z-score. Here, this z-score was rounded to 2 decimal places and then you found the answer. Here, we just put it in and we didn't have to round first before we asked for the answer. So just be careful. If you're running into any problems on your homework, let me know. Most of the time they tell you where to round first, or they adjust it so that things are okay. But again, if you're running into some issues, just let me know and I can take a look at the online homework to make sure it's not counting it wrong incorrectly. So going back to StatCrunch, we now have the capability to calculate, really, if I want to change that, I can. You also have the option to do greater than or equal to instead of less than or equal to. So this is very helpful as your problems get more complicated because the table method always requires that you do the less than or equal to and then calculate complements based on this. So let's go back and make sure we answered the question. If we wanted the proportion less than 35 inches, we calculated this 0.1203, and that's the proportion. If they'd asked for the percent, we could say approximately 12%. So then what I want to do next is just contrast a couple things that your homework might ask you to do. Your book starts off with this context, but you'll see some homework problems that also just say something like, determine the area under the standard normal curve that lies to the left of these values or to the right of these values. So notice your book and MyMathLab will pull up this table 5, but you can do this problem with StatCrunch as well. So under question help, I'm just going to open up StatCrunch. And if I wanted the area for the first one to the left of a z-score of 0.01, since you're dealing with a z-score, you know that you're using your custom distribution, or excuse me, your normal distribution. And anytime you're dealing with a z-score, you leave the mean and standard deviation 0 and 1. So in this case, the probability to the left is the less than or equal to. Notice StatCrunch will confirm your shading. And we have a probability that's close to 1/2. Notice this is close to half of the normal curve. Now, if they had asked to the right, we could just change this and go to the right. Okay, so make sure you're reading your question carefully to know which direction to do your shading. The last thing I want to indicate is the backwards. You'll see some problems here that tell you to find the z-score instead of finding the area. You can do this in reverse just by inputting the information you know and asking StatCrunch to find the missing piece. So pull up your distribution again. And if we want the z-score such the area to the left is 0.52, anytime we have left, that's going to be less than or equal to. And then we can change this to 0.52 here and compute. Notice what StatCrunch did. StatCrunch filled in this value and left the area value that we filled in. So what it's telling us is the appropriate z-score so that the area to the left is 0.52 is going to be a z-score of 0.05 approximately. A lot of times we'll round that z-score to 2 places. Let's say we had wanted that area to have been 0.75. In other words, shading to the left approximately 75% of the area. Then we could recompute and calculate. So be really careful that you're reading these questions, that it's to the left or the right carefully. Sometimes they'll change and give you area to the right.